So in a way, dendrograms, clustering, the results of clustering are data summaries, just like any other data summary. Similar to the t-statistic. The t-statistic is a data summary. The one big difference, though, is that while summaries such as the t-statistic are univariate, it's just one number, a dendrogram is not that simple. Right? It has many different aspects to it. So while we can easily describe how much a t-statistic varies due to chance, it's a little bit harder to show or to describe how clustering could have been different had we had another sample, had measurement error been different. But it is a random quantity. So I want to illustrate that to give you a sense of how strong the effect of variability can be on clustering. This is particularly important to keep in mind because in the literature you usually don't see uncertainty summaries attached to clustering, which makes some people believe that they're deterministic, that this is the only cluster that could have happened, that this is the final answer, when in fact they are random just like any other summary statistic we compute. So just to illustrate, I want to show you a simple example created with simulations, which you can see in the class notes. So for this simulation, I created 4 profiles based on 50 genes. So these 50 genes are different in the 4 profiles, and then I created from those 10 biological replicates from each group. I added a little bit of measurement error, and when I cluster these samples, we get perfect clustering and by group, which is not surprising. Each group has a different profile, therefore the distance between groups is much bigger than the distance within group. Now, this is actually a realistic example. Now let's suppose we run a microarray. The microarray, or we perform an RNA-seq experiment. Now we have the 50 genes that change, plus thousands of others that don't. So what happens when you add this to the simulation, when you add thousands of genes that don't change to the 50 that do? Look at how much the clustering changes, right? And no longer are the samples grouped by their original true profile. You can see there's 2s and 4s here, there's 2s mixed with the 4s, etc. So that's a very important fact to keep in mind, that clustering is also a random result.